The 1960s. In the midst of all the freaks, the fun, the trauma, and triumph, two researchers in Philadelphia discovered something about a rare but always fatal form of cancer called chronic myeloid leukemia, or CML. Many patients with CML had a strange-looking chromosome, number 22. It was shorter than it should be. They gave it a name, the Philadelphia chromosome. But what caused it, and what did it do? It was going to take many researchers and almost 3 decades to answer that one.
The elegant solutions that viruses have for how to live are captivating. They're, to me, the excitement of science.
In 1960, a young and promising graduate student, David Baltimore, began working in an equally young and promising scientific field, molecular biology. His interests? Not cancer, not the Philadelphia chromosome, viruses. Only he wanted to study them in mammals, not bacteria.
I asked people around MIT, where I started graduate school, did they think that was a reasonable idea? Did they think you could do it? And no one knew, because no one had any experience with this. So I went into this seemingly obscure field of RNA viruses. I was literally on the trail of anything that came my way.
After 10 years of experiments, what came his way was an unexpected discovery about cancer. The RNA virus he was studying could actually change into DNA. This was a clue to cancer because
it explained why an RNA virus could permanently alter the characteristics of a cell. It became reasonable to suggest that the virus contained a gene that could take over control of the cell. And that was, in fact, that is to today, the paradigm of cancer. It is a change of normal genes into genes that can take over the behavior of cells.
It was a monumental discovery, and for it, Dr. Baltimore became the youngest man to receive the Nobel Prize in Medicine. Research like this takes time and persistence, creativity and luck, and of course, money. Early on, one of Dr. Baltimore's mentors suggested applying to the American Cancer Society.
I said, but I'm not working on cancer. I wasn't then. This was much earlier in my career. He said, but the American Cancer Society understands that developments in basic molecular biology, particularly as applied to mammalian cells and mammalian viruses, even if it has nothing obvious to do with cancer, one day will turn out to be central to cancer. And so I applied, and I was supported ever thereafter by the Cancer Society, became an American Cancer Society professor.
The American Cancer Society first began supporting cancer research in 1946, in addition to all of its other programs. Today, over $2.5 billion have gone to research alone. Where did that money come from? It came from all kinds of people, especially after they met someone like Felicia Wilson.
My neighbor down the street called one day and asked me if I would work with Crusade. And I got involved with American Cancer Society that way and ended up chairing Crusade in Gwinnett County. I chaired our gala. I've also worked with Road to Recovery, taking patients to treatment, which is very rewarding, probably one of the most rewarding things I've ever done.
Some of the money Felicia raised in the 1970s and 80s found its way to labs like that of researcher Dr. Janet Rowley, who made the next discovery about the Philadelphia chromosome. For some reason, a piece of number 9 breaks off and joins the end of number 22 and vice versa. That explained why the Philadelphia chromosome was even shorter than it should be. But what did it have to do with CML? Everything. But finding that out was still almost 20 years away. And it happened in a lab where they weren't even studying the Philadelphia chromosome, Dr. David Baltimore's lab, where he was continuing to explore the enzyme he discovered and how it caused cancer.
What we did, Howard Temin and I did, in discovering the reverse transcriptase, was to provide the basis